We normally think of telekinesis as a kind of supernatural mental power, but the word telekinesis just comes from the Greek, kinesis meaning motion and tele meaning at a distance, and the real universe is full of telekinesis, or motion at a distance. I mean, what tells a ball to fall down when you drop it? Why do magnets repel or attract without touching? How does the sun heat us when it's millions of kilometers away? And how do cell phones miraculously transport your voice to the other side of town or the other side of the earth? Well, the sad truth about all these real-world telekinetic phenomena is that they aren't really action at a distance, as people figured out starting in the mid-1800s. Before then, we didn't really know why magnets could repel or attract each other from far away, how a ball could know that it was supposed to fall towards the Earth, or how the sun could light up the Earth. We just knew that they did, and this was a kind of spooky action at a distance. But into the world of physics came a London bookbinder's apprentice named Michael Faraday, and a young Scottish laird named James Clerk Maxwell. Together, Magnetic Mike and JC made one of the greatest discoveries of all time. Faraday was convinced by his experiments that magnetic and electric forces were not telekinetic action at a distance, but were really the expression of some underlying physical thing. He called that thing a field because it was away from the object, like students on a field trip away from school. Inspired by the cleverness of this idea, Maxwell sat down with pencil and paper and put together the experimental results with Faraday's hunch using beautiful mathematics. He showed that you could describe all of electricity and magnetism with the idea of a field, a single electromagnetic field which permeates all of space. The basic idea of a field, as envisioned by Maxwell, is that at every point in space there's a number which tells you something about that point. That number might be a simple number like the temperature at that point, or the number of cats at that point, or it might be a complicated number like the direction and speed of the wind, or the number of atoms of strawberry cheesecake that have moved past in the last second. Make a chart of those numbers for every point in the universe, and that's what a field is. So young JC realized that at every point in space, in addition to a number telling you the flow of strawberry cheesecake there are also numbers telling you the strength and direction of the electromagnetic field. The mathematical equations he used to describe these numbers also relate how the strength of the field at one point in space affects the strengths at nearby points and those at their nearby points, and so on. And it's this electromagnetic field and the way it changes from point to point that helps to explain how things like magnets and static electricity and your cell phone calls can have long-range effects without actually being telekinesis or action at a distance. For example, a magnet generates a disturbance in the field that looks like a magnetic field. And when you move the magnet, Maxwell realized that the bits of the field close to the magnet will change because the magnet changed its position. And then the bits of the field a little farther away change because the field next to them changed. And then the bits farther away and even farther away, and so on, like the tiniest bucket brigade in the universe, until they eventually push on another magnet, maybe a compass needle. On the other hand, an electron makes a disturbance in the field that just says, "Hey, get away from me," to other electrons. But if you shake an electron around, it'll send out ripples through the field, like waves on a lake. The awesome thing that JC realized was that these electromagnetic ripples or waves travel at the same speed as light. In fact, they are light. JC had discovered that light is an electromagnetic wave. And it's these waves which are the bucket brigade that transmits heat from the sun to the earth, or a signal from your cell phone to your mother's, or light from a light bulb to your eye. The only reason we think of any of these things as action at a distance is that we can't see the hidden bucket brigade going on under our very noses, but it's there, as countless experiments since Faraday's have shown. And so, Magnetic Mike and JC and their description of electromagnetic fields explained magnets and electricity and light without any need for telekinesis or other kinds of action at a distance. In the process, they laid the foundations for all of 20th century physics, because today, fields are the cornerstone of our understanding of the universe.